Hey guys, and welcome back. So previously we had talked about kernel configuration options. Now what I want to transition into is talking about how we can actually compile a kernel, i.e. what this means and how we would actually do such a thing. And then after that, talk about kernel installation. So we have a lot of cool content within this nugget right here. How about we dig in and get going then, shall we? So the first thing I want to talk to you about is really to answer a question, and that is, why on earth would you want to do such a thing? Why would you want to install a custom kernel? Well, the reality is, if you happen to be running some type of distribution such as Ubuntu, or maybe some type of Red Hat distribution, the reality that you would want to install a custom kernel, well, the probability of such a thing is quite low. That just is the general facts of the matter. But however, if you happen to be using something that is maybe a little bit more limited in its power, something like maybe say a Raspberry Pi, well, a Raspberry Pi, as you know, can be a very, very small device with limited power. This could be a perfect example whereby you want to have a kernel that is much leaner and a kernel which is much less demanding on the physical resources. And in this type of case, being able to compile and install a custom kernel may be the actual solution that you need. And moreover, it certainly is the thing that we have to understand for the purposes of the LPIC 2 examination. So even if you might think, well, you know what, I might not necessarily have a use case or a need to be able to compile and install a brand new custom kernel. Point is that we do have to understand this. So let's waste no time and talk about what this actually entails then. Now, to be honest, the idea of compiling a kernel and installing a brand new one, it can kind of be a little bit scary. And to be honest, so much of what this entails, all the different options and parameters that we have available with respect to compilation and installation, is way beyond the scope of the LPIC 2 examination. So what I'm saying here is that you don't have to be too stressed out trying to learn all the little details here. What we want to understand is a high level overview and understand some of the main commands that we would use to do such a thing. Having an encyclopedic knowledge and familiarity with the process is really not so necessary. So listen in with a keen ear to the process, but don't be too stressed about or too overwhelmed by the process. Now, in order to begin, the first thing that we have to do is to download some kernel source code. So where on earth would I be able to get such a thing? Well, I'm glad you asked. There actually is a dedicated website that we can get this information, and that is at kernel.org. Once we go to this website, we're going to see a whole bunch of different kernel images that we can get, all these different versions that we talked about when we talked about the versioning numbers. We can choose the version we want, download that and use it to compile our kernel and then to install that kernel. So the first thing that we should do is to go to this website and we will actually download some kernel source code then. So what I'll do is I'll go to my machine and open up my browser. Okay, so where we want to go to is kernel.org. If we search for this, or rather go to this, we can see here we have our latest release here, version 5.17.7, but we also have these different versions available to us. But for now, all I'm going to do is to get this latest release. So I'll click on this image here, or this link here should I say, and the download should begin. Now this should only take a few minutes, and as we can see here, the download has completed just about, and perfect. So what I can do now, if I just close this down, I can open up the terminal. Again, I'll change to the root user, and it would help if I would type in the correct password this time. Okay, so I'm in the directory for IPv0. I should go into my downloads folder where this download should actually be here. Now, we can actually see here this has something called XZ compression. This is a more modern type of compression. We actually discussed this when we talked about the LPIC 1 exam. And we ultimately want to extract the files that have been compressed. Now there are some caveats I want to talk to you about first. The command I want to use to extract is going to be the tar command. Now in order to be able to extract this type of compression, the XZ compression, The option I'm going to use is going to be -J. Now notice this is going to be a capital J. It's not going to be a lowercase. Capital J is what we need. And if I happen to just, in fact, let me show you, go into man page for tar, and I scroll down for a little bit, we can see -lowercase will actually allow us to extract bzip2 compression, but we notice it is .exe in my case, so be careful. When it's .exe, we're using capital J. So that means we can filter the archive through .exe. So if I press Q to quit, we have that knowledge in mind. Now the next thing that we have to understand is that there actually is a pretty desirable, in fact, certainly strongly recommended location to where we should actually unpack this kernel. Now try to remember this location. This location is going to be in the /user directory and then /src. This is where you want to place your source code. So think about this. If I go to this location, I go cd, I go into user src. If I do an ls, we can see here we have a whole bunch of different kernels here. What I now want to do is to extract this download right here using the tar command and extract it into this location, so we will have another folder just like all these folders here, but this time the folder will be Linux 5.17.7. So let's actually walk through this process then. So what I will do is I will say tar and I will say -J to run the XZ compression, and I'm going to say XVF to extract the files verbosely so they print out on the screen. And now I have to specify what it is I want to extract. Well, I want to extract this file right here, but I can't just specify the name of the file because the location of where I am in the directory and the directory tree is in user source. So I'm going to give the entire path, which in my case is home IPv0 downloads. But of course, this will be different for you. So pretty much just put in the path where the download resides. So I'll go into my downloads folder and then Linux 15.17 tar.exe. And because I am issuing the tar command from within this folder right here, user src, it's going to extract it into this folder, which is exactly what I want. This is the location I want to extract this source code. So if I hit enter now, we can see the extraction happen. Okay, so that is now finished. Again, if I do a pwd, we can see my current working directory. And now if I do an ls-l, we can see we have this additional folder, Linux 5.17.7. Now what I want to do here is I actually want to create a symbolic link pointing to this particular directory here, and I want to make the symbolic link called Linux. So I'll do ln-s to create this symbolic link, and then I'll specify the name of the folder, which is this one here, and I will give the symlink the name Linux. That means if I do an ls-l now, we can actually see we have a symbolic link called Linux pointing to this folder. So therefore, if I go into cd Linux, within here we have all of this information. Now, one thing I want to point to you, and this is important for the purposes of the examination, is whereabouts we can find our documentation. We can see here we have this directory here called documentation with a capital D. If I go in here and I do an ls right now, so this really is a path we want to remember: user, src, Linux, documentation. And within here we can find documentation doing things like explaining the actual modules at play here. Now at this stage what I want to do is to install some particular packages. I'm going to install make, something called gcc, as well as libn curses 5-dev. So if I hit enter right now, I will say Y, hit enter again. So one of the things we just installed was called make. If I do man make, it says here the make utility will determine automatically which pieces of a large program need to be recompiled and issue the commands to recompile them. Ultimately, this is what we're going to be using in order to stand up and compile our kernel. So I will go back to my directory right here and I'm going to say make help. Now within here we're going to see a whole bunch of different information. Now one of the things we want to do is to actually clean our system before we do anything. This is going to remove any configurations that may happen to be left over from an old compilation. Now we can see here we actually have three different options. We have the clean target, the MR proper target, or Mr. Proper as I like to call it, and the dist clean target. So I will use the clean target, I will say make clean. And now what we want to do is to create the configuration file. Now if we actually scroll on up here, we're going to see a whole bunch of different options that we have. So we have these configuration targets. We can use make config, or we could use make nconfig, or make menu config. We have all these different options. The one which I want to use is a menu-based configuration, which is going to be menu config, okay? Now before I start, I want to also install Flex and Bison. So I'll say yes. Okay, I'll clear the screen. I'll say make menu config, okay? And this now drops us into the graphical user interface. Now if I scroll on down with my arrows, I can go into particular menus. Let's say for example, I wanted to go into device drivers. I could hit return. And if you actually notice, we have all of these options. Now, if we happen to see an asterisk, this means that this particular driver here in this case is going to be built into the kernel. So you cannot even disable it like you could a module. Whereas if you happen to see an M, this means that it's going to be compiled with this as a module, something that can be loaded or removed. So if I wanted to change something particular, let's go into block devices, maybe normal floppy disk support, I can hit spacebar and change the module to an asterisk so that it will be built in to the kernel, or I can hit M to change it back to a module. Now if I hit spacebar again and again, it's actually going to be empty. And when it is empty, this means it's going to be completely unavailable. It cannot be loaded as a module and it will not be built in. It's just going to be unavailable. But for right now, I'll just leave this as a star. And now at the bottom here, I can use my arrows and I'll go over and click save. Now this part here is something you want to remember. This is the default name of the file where the configurations are going to be saved, .config. Okay, so if I hit enter to OK, and then enter to exit, and then arrow over to exit, and enter again, and lastly, one more time, we have exited out. And if I do an ls-l, we're not going to see this .config file because it is hidden. But if I do an ls-la, now we can actually see this .config file. So if I happen to go into nano.config, here are all the settings that we have for our configuration file that we will use to compile our kernel. One thing I want to talk to you about right now, and this is something we definitely want to be aware of for the purposes of the examination. We have two different kernel image styles that we want to be aware about. The first one is called Z-image. Now the thing to note about Z-image is that it is an older style of kernel image and it's limited to 512 KB. So very, very small indeed. Now we also have another kind of image and this is called BZ-image. Now one thing I want to highlight here is that this is often the source of incorrect information. People tend to think that because they see BZ, this is somehow related to bzip compression. This is completely unrelated. What BZ image is, it just means big Z image. Pretty much it's a larger version of Z image. Simply put, most kernel images are much larger than 512 KB, so the original Z image is not going to be sufficient. So now we have BZ image, which is going to allow us to handle kernel images above 512 kilobytes. So try to remember that distinction, really, really important. So what we would do then is if we wanted to compile this image, we would type the command make bz image, and that would actually take the configurations from our .config file and actually compile it. Now I'm actually not going to run through the compilation process right here. The reality is this would take about, well in my case, at least an hour of just watching the screen run. But once that actually completes, you will have your compiled kernel image. But we understand that the kernel itself is modular, so we also want to compile the related modules. The way we would then do that would be the next command we would issue would be make modules, and this one here would take even longer yet again. In my case, this would take probably a few hours to fully compile. But again, for the purposes of the examination, as long as we know these commands and understand what they're doing, that is more than enough. And once we have compiled the actual modules themselves, we want to install them. And we can install them using the command make modules underscore install. And that is going to take our compiled modules and actually run through the installation. The next thing we would want to do is we would want to copy the compiled BZ image we created, and we would want to copy that to the /boot directory. And then what we would want to do is to create what is called an init ram fs file. This is going to contain a mini root file system that has the kernel modules we need when the system is getting going and booting up. Now, the way we actually create this file is we have a particular command in Ubuntu, and that is called mk init ram fs. So this is the command we would use on Ubuntu if we were on a Red Hat based system such as Rocky Linux or CentOS. We would use mk init rd, okay? And what this utility does, it calls something called the Draycut utility. And Draycut is going to create the initial image used by the kernel for preloading block device modules. And finally, if you wanted to run this particular kernel, you could modify your grub configuration file and reboot into this new kernel configuration. Now, ultimately, this process can be very, very complex, much more complex than what we have to understand for the purposes of the LPIC 2 examination, depending on just how deep you want to take it, and it is a very, very long process. But really understanding the main core concepts at play here, this is what we want to focus in on. We want to make our BZ image, we want to make our modules. This will compile the image and compile the modules. We then want to install the modules with modules install. We then want to copy our BZ image we create up here to the boot directory. Then we want to create our init ram fs file, and then we want to modify grub to actually use our new kernel. And those are the core components and processes that we really want to be focusing in on. Okay, so I know that was a lot to follow for a single nugget. If you find it tough to digest all the information in one go, then I certainly would recommend that you rewatch this nugget a few times and take notes, just to help let the information sink in that little bit easier. Okay, doke, so I hope this has been informative for you, and I'd like to thank you for viewing.